Well, I'm going to be talking to you about fashion today, so that's why I try to dress well and also not to bore you. I promise that I have way more slides than the previous speaker. I have way less demos, but I think they're pretty, so at least we have that going, right? What I would ask you is to imagine your wardrobe and ask yourself, like, how many white shirts do you have and how many white shirts do you need? Right? And I guess a good number is like 4 if you're a regular person who likes to dress well. But if you would ask the same question to a buyer that works for a fashion enterprise, the answer would probably go from 4 to, because this is not an easy number to guesstimate, right? Because there are many variables that affect the number of white shirts that a fashion brand can sell. And to make it even more difficult to answer, they need to guess this number for 7 months from now, because that's how the fashion industry works, right? Seasons, and you always do for 2 seasons ahead. To make it almost impossible to answer, you work as a buyer for a fashion enterprise that has 20 brands under its roof. Each one of them has tens of thousands of clothes, and you need to estimate their number 7 months in advance. And these clothes are going to be sold through retail stores, they're going to be sold through e-commerce web shops, but they're also going to be sold wholesale, like to partners and to associates. The only way that you can do this and that you can guess this number correctly is by being data-driven about it, because every other way is going to be wrong. As a matter of fact, the data-driven way is also going to be wrong, but just the smallest amount. Because when it comes to selling clothes for a living, you absolutely need to have the right product at the right time, show it to the right customer, but also for the right price that they are willing to pay. The consequences of being wrong are going to be felt throughout the world, because this is a big enterprise. They produce and sell millions of clothing items. So if you make 1 million more or 1 million less, there's going to be more CO2 used, more water used, but there's also going to be a commercial impact on your business if you have too few clothes to sell and people want to give you money, but you don't have the shirts, or if you order too many and then you simply cannot sell them, right? The fashion brand, this fashion enterprise that I'm talking about is built up of 20 companies, essentially 20 startups that are trying to work together. And why I say 20 companies, because they all have their own separate employees, their own separate budgets, their own separate decision-making processes, which gives them the agility to deliver quickly, to make business decisions like on the spot. That's great for the business. Where it isn't so great is when you don't have a central place from where the technical decisions are governed, such as about data storage systems. So that's when you end up with having small databases, big databases, those in the cloud, those on-premise. Some of them are unavailable. You have Excel files on the laptop, and it's all considered data sources that you should use as a buyer to estimate the number of white shirts that you need to order. And that's impossible. You need very good data to have a very good number. But you cannot have very good data if that data is siloed, unavailable, not governed properly. And I think you see where this is going. We realized this, and we decided as a company to build a unified data and analytics platform that is going to serve all of these 20 fashion brands, something that will help them turn this data that is kind of a byproduct of their business into an integral part of the business, something that's going to give them answers to the questions that they may be having, such as, how many white shirts do I need? So we decided to break down these silos. We decided to provide actionable data to anyone in the company that needs it. And we also decided to build it with Terraform. And today I would very much like to show you why we think of Terraform as a game changer for us while building this data and analytics platform in a fashion enterprise, and how it worked for us. So who's us? The company is called Bestseller. It implies that we are best at selling. How many of you have heard of this company? 1, 2 hands. I know you work there. You might be lying, I don't know. Just kidding. Yeah, that's usually the answer we get. But essentially, it is the company that is behind these fashion brands. Like if you bought anything from Jack & Jones or Villa or Mamalicious or Name It or any of the 17 others, thank you. You've paid my salary. My name is Ivica, and I work as a lead infrastructure engineer that is still building this data platform and using Terraform to make it so, to help brands and to help people that work for those brands answer questions about their business. But what my team delivers is infrastructure, tools, processes, standards, something that doesn't have, direct value to the business. That's why there's an army of data engineers that are going to be using those tools and processes to crunch the numbers, to parse data, to clean it up, to massage it, to make data products out of it. And when I say a data product, it might sound silly, like, what is it? I'm an engineer. I like to know what things are. Think of it as a view in a database, a schema in a database, an Excel file that you can use that will tell you the right information, that has value. Like that's data that is clean and that has value on it. Those data products on their own don't really do anything, but that's why we have an even bigger army of data analysts, of business analysts that are going to be querying those data sets, using those data products to essentially draw conclusions, to get numbers, to get trends, to understand the past, and to try to predict the future, both of very difficult to do. But in the end, those conclusions will be used by the management team, the topmost layers of the management team, to make decisions about the business. Which country do we expand to? Which carrier do we use to deliver our packages? Why is the return rate so high? Right? These are essential questions to the business. And the data platform is there to help people that understand data answer those questions. In its most basic form, a data platform enables this: loading of raw data, transforming it, cleaning it up, massaging it, making it useful, and in the end, serving this as data products to whoever might need it. The success of this platform is going to depend on the number of producers of data and the number of consumers. The platform on its own has no value. So having that in mind, we were also very critical when we were deciding on the tools and the processes that will help these teams and these people use the platform itself. So by standardizing on a good number of things, we help them move faster while also keeping the platform secure and governable. So we've talked about the producers of data and consumers of data, and the way we typically separate them is into domains, such as the retail domain or the finance domain or logistics or anything that you can come up with. So you would be very right to ask a question, what is a domain? Again, I'm an engineer. I like to know what things are under the hood. So what is a domain in practice? So it very much depends on who you ask, right? If I was a security engineer, I would say it's a security boundary, because it does guard your data with tools and protocols. If you ask a typical data engineer what is a domain, they would tell you, hey, it's just a grouping of data that belongs to the same category. E-commerce, retail, logistics, these are all similar data that belongs together. And if you're something like me, like a platform DevOps engineer, it's just a bunch of Azure AD groups, Snowflake roles that do the thing that you want to provide to your consumers. And the first reason why we think Terraform is a game changer for us is because we can take this fundamental building block of the platform, the domain, and we can treat it as infrastructure. We can manage it with Terraform. Super nice. So what you see on the screen is an example, a real module, a real example that creates, for example, the finance domain with a few owners. 2 in this case, John and Jane. In a nutshell, this domain is going to create 10, 15, 20, I don't care about how many resources, but that's not really the point. The point is what it enables for the company and what it enables for the platform. First of all, by setting very clear ownership, it allows anyone outside of this domain to understand who owns the data, who is responsible for the quality, who should they contact if they want access to this data. On the other hand, by using Snowflake roles, sets up the correct permission structure, role-based access control, and it enables governance for us centrally, again, through code, through Terraform. And because it's a module, what you get self-service. You get growth. As a matter of fact, my team, I don't remember when was the last time in the last 3 years when we used the module. It's always our stakeholders that use it because they know what should constitute a domain, so they just create them on the fly whenever needed. But the domain on its own doesn't really do much. That's why we need the almighty database, and that's why I asked Sam, hey, can you generate for us a Snowflake database and a few roles, because I wanted to see if I'm going to be out of a job. No. That's good to know. It was cool seeing it, but there's a lot more to it than just simply creating databases and roles. So what we have to recognize here is that the database is, that's why I call it the almighty, that's where the value is. That's where the data is going to be. So it is a core of a domain. And again, we can manage this with Terraform. Again, a module with a few simple inputs. It allows our stakeholders to use this. And the number of resources, 50 plus, I don't even know, 20 data sources to make it all work, to make it all happen. But what it enables for the business is far more important because it enables sustainable growth through, again, being self-serviceable. Use the module, provision what you need, go about and do your job. 10 minutes, you're up and running. No need to involve anyone else, right? That's the beauty of Terraform and modules. But by also using this as a cookie cutter template, we can put governance layer on top of this. We can put tags so that we can do cost reporting centrally, cost optimization centrally as well. And by building two databases together, what you start to create is called a data mesh, where you have two of them. You can combine the data from both, to put it simply. So to give you an example of this, if we look at the two domains that I mentioned in the beginning, the one being retail, you could always have a brand manager, let's say someone sitting in the Jack and Jones office, and they ask, how many shirts did we sell last year? It's a fair question. They want to understand how they did, how their products are doing. But if you can do this with just one database, imagine what you can do with two, or what you can do with 10. So to just extend the example to having the retail and finance domains, you can now answer the first question, how many of them did we sell? How much did we earn on them? Oh, and by the way, are the red ones a good product? So you can filter this data and you can very quickly understand how is the portfolio of your products doing. Could be fashion, could be car tires, could be, I don't know, ACs, whatever. The principles stay the same. How does a data mesh look like with Terraform? Well, it's quite simple. The database that is going to be written to by someone working in the finance domain, they own this, they know what should be inserted. And we said, okay, someone sitting in the retail domain or someone working for Jack and Jones would like to read, so we can simply grant them the permissions to read this data set by making this code change. For us, this is the game changer number 2, because the data mesh is born, and it's also allowing for infinite combinations. If you have 5 domains, if you have 50, if you have 500, the combinations are really going to be infinite in the answers that you can deliver to your management team. So you could do things such as combine the e-commerce, the wholesale, and the retail numbers, and you can definitively answer the question, how many shirts in total did we sell across all sales channels? You could also go a step above. You could combine these 3 domains, such as HR, where you can get people working hours. You can combine the data from the legal domain, such as what's the price of this retail store monthly? So we're paying a lease. So how much are we paying in the leasing contract? And also, how much did we sell in that particular store? So you can understand which stores are profitable. And why is this important? Well, it's important because the business is ambitious. And one of the goals, and I hope I don't get in trouble for sharing this, is to open 2,000 retail stores a year. So if you open 2,000 of them, you absolutely want to understand how much of them are profitable and which aren't, right? Combinations are really infinite. Terraform allows this, right? And this data mesh is managed with code, which means that, again, we get all the benefits of using code, right? You get version control. We get to use code owner's feature of GitHub, giving a owner of a domain full ownership of who can access their data. Because managed through code, there's a pull request, and they can simply reject and say, no can do, mister. There's sensitive data here, you cannot see it. One of the first challenges in the past 2.5 years was, of course, this one. Every stakeholder ever has said, I don't know Terraform. And that's very fair. These people do data engineering, they do SQLs of 1,000 lines, they know their stuff, but they're not Terraform users. So we definitely understood that there needs to be an asymmetric complexity in the way we build things. For us, the complexity should be high. This is what we deal with, this is what we do every day. But for our users, the complexity should absolutely be low. And this is a simple approach that we are trying to use every day. When designing these modules, go with a simple interface. Go with the safe defaults. Code that you don't have to maintain is the best code. For our stakeholders, if they can change one line, that's good. If they can change 0 lines, that's even better. Use as much data sources as you can, and also use a similar interface across all of your modules. We have around 20 of them. And then again, share knowledge. Do the documentation, right? But no one likes to read. So do trainings, do office hours, do success stories. Find champions within the teams that are using your tool, using your module, and have them tell the story. It's going to sound better because it's one of them saying it. It's not you, saying my horse is the best. And of course, version the modules, right? It's a good practice. It's what you should be doing. Yes, to keep breaking changes behind the feature flag, but also so that your stakeholders don't experience failure, because you have control here. And if they are unsure about Terraform as a tool, if they see a plan that has something red in it, they will gonna say, not my job, please come fix this, and it will be a sore thumb in their developer experience and in their user journey. Cool. So as I said, it's all about minimizing the cognitive load. So looking at the example of this finance domain module, the only thing that our stakeholders need to change is these lines. Again, simple lines. It's a simple array. If you come from any coding background, you would have an easy time making this change. Absolutely. The same goes for the Snowflake database module. Again, the only thing they need to touch is these lines. Copy-pastable, absolutely. To also not to downplay it too much, the same database module can be quite complex in the interface, because if you really want to nail down who can see what and when, you can absolutely complicate it. So you could grant different roles to have the write permissions. You could have multiple roles having read permissions, but you can also have per schema permissions. If you want to limit what one fashion brand can see in terms of data, you would put that specific data into a single schema and allow them only to see that schema. There's laws around it. You absolutely have to do it. Otherwise, 1.5% of your revenue is the fine. Good. As I said, another thing that we are trying to do is to keep the module interface consistent. So what you see on the left is the module where the analytics database is created. On the right, it's a storage account for on Azure. Same interface, almost copy-pastable across them. It goes even further. Even the permissions to the database and to the storage account are also managed in the same way. Even though behind the scenes, right, everything is it's different resources, differently implemented. It's a different third-party provider after all. But for the end user, for our stakeholder, looks the same, feels the same. Good. Another challenge was being far too downstream in the release process. So when Snowflake releases something, a feature, I think it goes roughly like this, don't quote me on that. It goes into public preview, then GA, then it becomes available on AWS, then Azure, and then finally it lands in Terraform, and each one of these can really take months. And we are, of course, here on the back of the queue. It gives us time to understand the feature from the documentation before it lands in our lab, right? But it also creates this friction because, as I said, this is 20 startups working together. This is 20 startups competing against one another and then competing with their competitors on the market. So one of them grows big, congrats. And all of a sudden they need a new feature, hybrid tables in this case. We have to provide it, but this is AWS only, and we are on Azure. There's two options for us, right? We can just tell them, come here next year, and I cannot swear because we are all live, right? But they will be very colorful in their language. We can always tell them, hey, go somewhere else, and they will be happy to because it's business. They need to deliver. They don't care about Terraform or Azure or Snowflake or whatever. That's not what gives value. Or we can do something like this. I hope you can read it in the back. I tried to make it a bit bigger. You try and see how it goes, because this feature is available on AWS. So I have my colleague, he sat down, he tried to build this. Roughly 28 minutes later, I see the CI is green, I see Terraform plan happily saying, I'm gonna change this and that, I'm gonna add this and that. And I even comment, you cannot see this, but this is working too well, because I'm stumped, I'm surprised, why is this working? 28 minutes later. So what happened in those 28 minutes? If you're working with Terraform, this is old news to you. You use this every day. Create a provider, give it an alias, use that alias provider with your module, boom, it works. What happened is in those 28 minutes is we became multi-cloud data analytics. We were running on Azure and we were running on AWS, like this. They gained competitive advantage in 28 minutes because they got their feature that they wanted. They got better performance out of this feature. They got lower cost in 28 minutes. We got some bragging rights. I can come to an event like this and I can speak about it. But this is why Terraform is a game changer for us, because we could deliver all of this with a simple feature of a tool that you have been using every day. But the end result is huge for them because they get all of the benefits of being multi-cloud, of being competitive, and of having a lower cost while doing so. Another challenge that we were facing was that the Snowflake provider was under heavy development. For 2 years, 2.5 years, very heavy development. And you can say it's a good thing, right? Because you get new resources, you get improved security. You also see commitment from the company because Terraform is an interface. If I had to click through the UI or use SQL, God forbid, I wouldn't be employed, right? But because I can do it with Terraform, it shows commitment. It broadens the user base. It also means that you get breaking changes in a version such as this one. Not cool, really not cool. We also saw some amazing growth in 2.5 years. We grew 4 times over in every possible way. New stakeholders, new domains, data sources, data products, pull requests, 2,000 of them. Super nice. But we had to stop upgrading the provider because of those breaking changes, because of the pace of development, because with every new upgrade, we were getting more and more deprecated resources, and it just was scary. Dudes, I can tell you it was scary, and you'll figure out why soon enough. Then when version 1.0 was announced, a stable version, plenty of breaking changes, it was really time for us to migrate. For us to stop the growth for a bit, focus on getting it stable, focus on getting it ready for the next phase of growth. But we also had 5,000 deprecated resources, and we were 2 years behind on all possible upgrades, like everything. We missed everything to allow for this growth to happen, right? It was a trade-off. So the migration kind of looks like this. You have 3 layers that you need to change and reconcile to be up to date. There's your Terraform code in your modules, in your resources, whatever. Most of the time, this will change. There were plenty of breaking changes, plenty feature changes, all good, all in your control. Then there are the Terraform resources in the state for the Snowflake objects that were created, and this might change. Still good, still all right, but then you have a live system that must not change. You have an amazing growth, you have 60 domains, you have 1,000 stakeholders, roughly, and they depend on this. This is live, this is in production. Good. This is a statement, and let me see a show of hands who thinks this was a difficult thing to do. Upgrading 5,000 resources across 3 environments on a live system in 1 month. Was it difficult? Okay, a few of you are brave enough. One more, thank you. Actually, it was boring. It really became boring. The first week was rough and tumble until you figure it out. But because we had these version templates, the change needed to happen in one place and then propagate it. We were fully in control. We also had very strict environment separation, so we could, play around, learn in dev, see how it goes in test, and then and only then roll it out to production. We are also very streaky and nitpicky, and that's my whatever diagnose hitting there, but there is a very consistent naming scheme across everything. And people hate me for that, but yeah, I get to reap the benefits of that, because when you have a consistent naming scheme, you can do greps, you can do counts, you can do all the good stuff with all the good tools that you develop or that you did not develop, so you can just automate this. Once you have a process that works, it's a bash script, it's 2 for loops, it's done. And also, it was easy because we built 2 helper tools to help us go through this. One of them is open source. I'm gonna plug it in soon. This is where we realized that Terraform is a game changer for us, and it is the way for us because it is not in the way for us. It does enough, but not too much. It allows you to build and rebuild and evolve. Want to change the state? Want to be a surgeon? Cool, go ahead. It's open for you. I was searching for some features in the language itself, in the tool itself. And more often than not, I saw core contributors or maintainers of Terraform reject pull requests, reject requests for features. And the reason was simple enough. We don't want to bloat the tool with this. It's a cool thing. We applaud you. We thank you for the contribution, but it maybe belongs in a provider of its own and not in the core feature set. That's a very mature thing to do. Because by doing this, what they are doing is they are balancing what the tool can do and what it cannot do. And because of that, it plays along nicely with your grep, with your JQ. It plays along nicely with the tools that were built 50 years ago. By using JSON as the output, it plays along with almost anything that is available today. such as the tool that I've open sourced. Who uses Terraform Validate here? Good, nice, as you should be. I love it. It was an instrumental tool in upgrading these 5,000 resources because it will tell me, hey, this is what's wrong. This is where you go and fix it. It's native to the tool. It's native in the ecosystem. It outputs as JSON, so perfect. But in my case, it was 50,000 lines of JSON. That was a bit too much for me to look at. And I thought, okay, I can do something around this. I can build a simple tool, a GUI tool, because I want to share this with the world. Not everyone is a fan of a CLI, that allows you to open this output and filter it. Search through it, figure out what resources, what warnings do you have, what errors do you have, and which resources are going to be affected. So by opening my test file, I can see that it has like 2,000 warnings. That's a big number. But actually, if you search for a specific resource name, so let's say that you want to fix, I don't know, an AWS VPC, or you want to upgrade the security group resource, whatever, Snowflake in this case. You search for the resource name, you say, show me everything that contains this string, and all of a sudden you go from 2,000 resources to just 60, which is way easier to deal with and to work with and to put in your brain. But you also can use the only unique toggle, which will again show you just unique version of this resource, of the warning about this resource itself. So you go from 2,000 to 1. And because it's just 1, it shows you where exactly this resource is. Open the module, fix it, run validate again, all green, all good. So you went from 2,000 warnings to a fix by using this simple tool. Good. One of the major goals for Bestseller as a company is to be sustainable in every possible way. Production, energy generation, but also the way we build our systems and the way we build our platforms. Being sustainable in that case means that adding new data products doesn't mean that you need to hire more data engineers. If you need new features on the platform, it doesn't mean that you need to hire more platform engineers. Do more with less. So, what is more, what is less? I can tell you that we have been outnumbered for the past 2.5 years. On and off, we were 3 engineers in the team. That's it. We directly serve 70 to 80 stakeholders within our department. So these are the people that will do crunching of the numbers. These are machine learning scientists. These are the people that are hardcore data enthusiasts. What they have is roughly 1,000 stakeholders, direct stakeholders that will use the data products that they have built. And in the end, the business itself is several billion euros in turnover every year with 3 engineers in the platform. I think that's the definition of being sustainable, and that is where we saw that Terraform really is a game changer for us because it is a great amplifier of what we are doing. Build a module once, validate that it works, and give it to your stakeholders so that they can generate value with it. It doesn't matter what it is as long as it generates value. We saw that it works, absolutely. A data analytics platform can be built with Terraform successfully, but we also saw that it's far from perfect, right? I'm not going to lie to you. So what's next for us is isolation, smaller states, faster applies without an approval maybe, because at the moment code is it's a monorepo. It's a bunch of Terraform files. 200,000 lines easily of Terraform. It's too big for anyone to understand. So we need to break it apart. We need to keep it smaller. We also saw that our modules need to be reworked because when we started building them, we didn't know what we didn't know. And our stakeholders didn't know what they don't know. So we went very wide. We went very simple, big Lego blocks. One module does one thing and one thing only. But now we think it's time to make them do more than one thing, make them easier to use for humans, but also for automation. Just today we saw an MCP server example. So if you build your modules to be usable by something like AI models, we can have even more growth. Absolutely more policies, more checks, more rules. That means I don't have to look at the pull request, I don't have to look at the CI run. Again, more growth and faster growth as well. There is also a big plan for us to now go from 70, 80 direct stakeholders to a department with 400. So that's a big step up. We have opened one more spot in the team. So we think, if we can handle 70, 80 with 3 people, we should be able to handle 400 with 4 people. Why not? Let's try it. Good. So to get to the takeaways, I have a little story for you. I live very close to the Schiphol airport. Lovely airport. I'm so close that when a plane lands, and if I look at it, I can see the windows. I can see the company name that it belongs to. My daughter loves them. She's just like, and they are frequent, right? So a question for you. When you look at the Schiphol airport, it has 6 runways. Those in purple, what do you think? Are they used for landing? And those in gray are used for taking off. Who thinks this is correct? Okay, 3 hands up. So I'm just going to do an inverse. The purple runways are for taking off and gray runways are for landing. Is this true? No. You're all right. But also looking at the scale of the airport, they have roughly 1 takeoff or landing every minute, 365, 24/7. So it's a busy airport. But it was a trick question, because all runways are used for landing and for taking off. Right? That's what you meant, I think.
Yeah, with the wind direction.
Absolutely. And also with other factors as well. So wind direction, time of the day. People living around are complaining about the noise. So that's why you don't see big cargo planes landing at 3 in the morning. It would wake everyone up, right? So what the management of the airport is doing is they are adapting to humans and to nature. They are planning, they are measuring, and they are adapting. And I think this holds true for the data and analytics platform that we built with Terraform. If you know your stakeholders and if you tailor the platform to them, if you treat everything as infrastructure, and in the end, if you plan and measure and adapt, you can do this, you can win this. But if you also think about, are you building the right thing wrong, or are you building the wrong thing right? With these words, I would like to thank you very much for staying until the end. If you want to hit me up here. It was a pleasure. Do we have any questions? Please.
What were some of the biggest challenges or issues that you faced offering Terraform to other teams, so they had to use it like that?
They ranged from, I understand Terraform, but I don't like it. I have an opinion about it, and that's it. I can copy-paste, that's good. To people saying, I don't care about your plan. I don't understand it. I don't want to think about it. I want it to be a magic wand. And then I would, if I were to phrase it differently, there's a different skill and competency set across all of these stakeholders and across all of these teams. Some people will naturally enjoy doing something else other than SQL and Python. Some of them will not care about it. So ultimately, it's our job to help them along. Even though everything is self-service, ultimately it is our job to help them set everything up.
And what eventually convinced them, or were they forced to use it?
There was no force, right? There's no force. It is a collection of tools and standards, but it's not a collection of, handcuffs or whatnot. You try to share success stories. You try to show the impact. We have recently had a, how do I explain this? Service accounts for machines connecting to Snowflake. They should be using private keys, no passwords. And this is something that comes from Snowflake as a platform for increased security, etc. But there is now a transitionary period, and every once in a while we would migrate some of those from passwords to using keys. We did it in such a way with Terraform so that when I update the service account, any connection to Snowflake is also going to get updated to automatically use this private key. So no change for the end user. Unless you as the end user do not manage your connections with Terraform. You do it clicky, we make a change, password doesn't work anymore, and you get woken up by PagerDuty because your data pipeline didn't go through. So instead of telling them, no, you have to change this, you approach it from the impact. Like, if you manage this through code, it is seamless. Rotation of the credentials, you do not see it, you do not feel it. And your data pipeline doesn't get broken. The report that goes to the CEO, like literally in this case, doesn't get broken. So it's not a matter of you have to, but you should, and here's why. Anyone else? Pizza time, I guess. Thank you very much again for being here.